Today we are taking notes over systems of equations, and we are going to solve systems of equations by graphing. A system of equations is a set of two or more equations with the same variables. We'll focus with variables x and y. Solution of systems of equations is when all of the lines, or where the lines intersect. Go ahead and hit pause if you need any more time to write these down. When we are solving systems of equations, there are three possibilities at all times, and we're going to see those three possibilities today when graphing as well. So one solution is when the lines intersect at one point, which is not always an integer, and what that means is that the lines might not always intersect at a perfect corner or blue corner on your graph paper. The second option is no solution. We saw this when solving equations this fall when we had variables on both sides. And when we have a system of equations and we graph the two lines, they will not intersect. For lines to not intersect, that means they are parallel, and that would mean they also have the same slope, if you recall that from the Overland Trail unit. The third option is called infinitely many solutions. And that is when you're going to graph two or more lines and they are going to produce the same line. That means that they have the same y-intercept and the same slope. Again, if you need more time to write these three definitions down, go ahead and pause and hit play when you're ready. Our first example here, we're going to graph two lines, y equals 3x minus 4 and y equals x. Our first line has a y-intercept of negative 4, and it has a slope of 3 over 1. I go up and to the right because it is positive. We're going to go ahead and graph a solid line. Go ahead and update these both here. We want to make sure you're drawing your lines with arrows and do a really good job about getting through your points that you plotted. The second equation here has y equals x. This is the most basic equation. Remember, this is the parent equation because it has a 1 over 1 slope and a y-intercept of 0. So our starting point is 0. I'm going to grab a different color here. It has a perfect 1 over 1 slope. And if it's positive, we go down and to the left. I'm going to go ahead and grab another line tool here. And notice that these two lines intersect at one ordered pair right here. And so we're going to write that solution as an ordered pair, x comma y, over 2 up 2. So the solution is 2 comma 2. And that is one answer. I would like you to go ahead and hit pause on this video and graph both lines here for number 2 and write your answer as an ordered pair. And when you are ready, go ahead and hit play. Alright, so you have now tried example number 2. Let's go ahead and see if your lines are the same as mine. So we're starting at positive 1 on the y-axis. Our slope is 1/3, up 1 over 3, down 1 over 3. We're going to go ahead and graph our line. And again, we want to make sure that you're using a ruler, getting these through the points. Second line is starting at -4 for a starting point. And its slope is positive 2 over 1. 2 over 1, 2. Oh, I did not start at -4. Started at -3. So starting at -4 down here, up 4 over 1. Or excuse me, slope of 2 over 1. All right, and line tool here. Intersecting, and our ordered pair is over 3 up 2. And so this is again an example of an ordered pair or systems of equations with one solution. All right. Ready for example 3 here? On example 3, we're going to notice our first starting point has a -3, and the slope is positive 1 over 1. And ruler, grab your line. Second line is starting at -1, and it also has a slope of 1 over 1. So this is again an example then. These lines will never intersect. They have the same slope. These lines are parallel. And so your answer for the system of this equation is no solution, because we will never have a ordered pair where these lines would cross. And on to example number 4. So in example number 4, we have one equation like we've just been working with in slope-intercept form. Our second equation here is in standard form, so we're going to graph it using intercepts. And I would like you to go ahead and hit pause again at this point and graph both of these lines. And when you're done, hit play, and we'll see how you did. All right, so example number 4, we are starting our first equation with a y-intercept of 2, and the slope here is -1/4, so up and to the left, 1, 2, 3, 4, and down and to the right. This next equation has a x-intercept 16 divided by 4, so 4, and a y-intercept of 2. So we're going to go up here, we're going to plot a point at 4 on the x-axis, and going through the y-axis at 2. And with that, they are both crossing through the ordered pair, 0, 2. And so that is the answer for the systems of equations. Example number 5, we can see here that we have a horizontal line using Hoy. So we're going to go to 3 on the y-axis and draw in our horizontal line. And we're going to start at -1 on the y-axis for equation number 2, and it has a slope of +2 over 1. And so there are 2 lines that are going to intersect. And the ordered pair here is over 2 up 3. Alright, so we have 2 more examples here for you to try. Example number 6 and 7. Oh, we have 3 examples, and number 8. So we'll go ahead and do number 6 together, and then I'll have you try the last 2. So on example number 6, both of these equations are in standard form, so we're going to go ahead and use the intercept method for both of them. So intercepts on example number 6 would be x equals 12 divided by 4, because remember intercepts are plugging in 0. So 12 divided by 4 is going to be 3, and the y-intercept is going to be 4. While I'm here, let's go ahead and find the intercepts for example 6, and for the second equation here, x equals -2, and y is going to equal a +4. So plug in 0, divide -24 by -6, bring it a +4. And we're going to go ahead and plot those points. So over to 3 from the x-axis up to 4, and construct our line. And line number 2 here, we are starting at -2 on the x-axis and going up to +4 also. And so then our lines, that was a horrible line, is going to go through both ordered pairs, and that solution is going to be 0, 4, where those 2 lines intersect. So at this point, go ahead and hit pause and try the last 2 examples and then see how you did. Alright, now that you've tried example number 7 and 8, let's go ahead and check those out. And we will see here, this first example has a starting point of +3 and a slope of -2 over 1. We'll draw a line through there. Equation number 2 is starting here at also +3. And then we can see that its slope is also -2 over 1. So both equations produce the same exact line. And so what that means is there are infinitely many solutions, because both of these lines extend forever, and all of the ordered pairs on that line would always make both of these equations true. And lastly, example number 8, back to plotting both of these with intercepts. 12 divided by 4, so we're going to start at +3, and 12 divided by -6, we're going to start at the y-intercept is going to be -2. For the second equation here, the x-intercept is going to be 2, and the y-intercept is going to be 4. So the first equation is going to be at +3 on the x-axis negative 2 on the y-axis. So we're going to draw in our line. And then the second equation is going to be at positive 2 on the x-axis and positive 4 on the y-axis. And we are right here, we are going to notice that we have an intersection that is not a perfect intersection. Let's double check. 12 divided by 4 is 3. 12 divided by negative 6 is negative 2. 3 and negative 2. 10 divided by 20 divided by 2 is 2. 10 is 2. 20 divided by 5 is 4. And so sometimes we have intersections that are not perfect, and so that's going to be an example here. It's over about 3, down 1.5. This is going to be an example where we have to use algebra, and you will not have any answers like this on your homework tonight, but we will learn how to find this exact answer when we get into our notes over systems of equations using substitution and elimination. At this point, we'll go ahead and start our homework over systems of equations and inequalities.